My name is Mandeepa from CSC B section. Today I am going to give a presentation on the topic long short-term memory or LSTM. In this presentation, I will explain that what is LSTM is and why it was developed and its architecture, how it works and its advantages, limitations, different variations, and its practical applications. Let's come into the introduction of LSTM. So LSTM is commonly called as long short-term memory. Is a type of recurrent neutral network or RNN. It is designed to work with sequential data. Sequential data means where the order of information is important. For example, sentences, speeches, and time series data. One major problem with the traditional RNN is vanishing gradient problem. Because of this problem, RNNs may find it too difficult remember information for a long sequence. And LSTM was developed to overcome this limitation and to help neutral networks remember important information for a long period. LTMs are widely used in areas such as language modeling, speech recognition, and time series forecasting. And next, uh, coming to the motivation for LSTM development. Now, let us understand why LSTM was developed. So, traditional RNS can struggle to learn uh, long-term dependencies during training. Gradients may become very small, which is known as the vanishing gradient problem. In such cases, gradients can also become very large, which is called the exploding gradient problem. Because of these problems, an RNN may have difficult remembering useful information from earlier parts of a sequence. So, LSTMs were introduced to capture and remember information over extending sequences. So the main feature of LSTM is its gating mechanism. These gates control the overflow of the these gates control the flow of information and help the model decide which information is important and which information can be removed. Uh, so the architecture incorporates gating mechanisms to regulate information flow and maintain relevant contents. Next, coming to the LSTM architecture components. Uh, an LSTM contains three main gates: input, forget gate, and output. Uh, in the picture, we can see the architecture of LSTM, and this one is called as input gate, and the middle gate is forget gate, and this one is the output gate. So these gates control the addition, removal, and output of information. Another important part of LSTM is the cell state. We can think of the cell state like a conveyor belt. It allows important information to flow through different time steps while reducing unnecessary changes. And the gates work together with the cell state to manage information efficiently. How LSTM works. Uh, so let us discuss the working of LSTM. At each step, the LSTM receives the current input and information from the previous gate. So here we can see the diagram of LSTM work. So for every step and every time, the input is taken from the previous gate. And next, the forget gate decides which existing information should be removed because it may no longer no useful. So finally, the output gate. The output gate controls which information should be removed. Uh, Output gate controls what information should be provided as the output. So input gate is taken from the input from the previous gate, and the output gate is decided to which information to give as output. And in this way, LSTM can manage information throughout a sequence and maintain the relevant context. And next, coming to the advantages of LSTM networks. LSTM has several advantages like first, LSTM are very efficient at modeling long-term dependencies in sequential data. And next is vanishing gradient problem. So it helps to reduce the effects of the vanishing gradient problem, which allows model to learn more complex problem. Next, the third one is LSTMs can be used for many different tasks. For example, they can be used for text generation and machine translation and speech synthesis. Therefore, LSTM is useful architecture for many applications where understanding the order or context of information is important. Next, coming to the limitations of LSTM model, LSTM can be computationally intensive because of the complex gating mechanisms. And the second one is they may require amount of large data and careful tuning to achieve good performance. And the third limitation of LSTM is LSTMs processes sequences sequentially. Because of this, parallelization can be limited, which can affect the training speed. So, although LSTM provides good performance for sequential data, it can require more computational resources and training time. And the variations and improvements of LSTM are one important variation of is the gated recurrent unities or GRU. GRU are a simplified type of recurrent architecture with fewer gates. Like another improvement is the use of attention mechanisms. Attention can help the model focuses on the most relevant parts of the sequence. There are also bidirectional LSTMs. They process the information in both forward and backward directions, which can provide better understanding. These variations help improve the performance and flexibility of sequential models. Next, coming to the practical applications of LSTM. LSTMs are widely used in language modeling and machine translation, and also used in speech recognition. So where they can help processes audio signals and convert them into signals. Apart from these applications, LSTM can be used in financial forecasting, bioinformatics, bioinformatics, and anomaly detection in time series data. So these applications shows the LSTM can be useful in many real world situations. So uh, where the data comes in a sequence. And next, coming to the conclusion and future directions. So long-term short memory is an important concept in deep learning architecture for working within sequential data. So it was developed to address the limitations of traditional RMS, especially difficulties in learning long-term dependencies. Although transformer models have become very important in modern deep learning, LSTMs still remain useful for sequential modeling. So future research continues to focus on improving LSTM efficiency and combining LSTMs with other deep learning technologies. So this is my presentation on long short-term memory in deep learning. Thank you, sir.